Is a generic drug is used to on a particular condition has a success rate of 51%. Companies developing two new drugs, drugs A and B to treat the condition. They carry out clinical trials on groups of 500 patients suffering from the condition. The results shown that drug A was successful in the case of 296 patients. The drug company claims that drug A is more successful in treating the generic drug. Use the hypothesis test at the 5% level of significance where there's sufficient evidence to justify the company's claim. State the null hypothesis and clearly state your conclusion. Just wants the null hypothesis, okay? Null hypothesis is nothing has changed. It's always nothing has changed, okay? Yesterday we said it has changed. That's why we got the mix-up, okay? So what it says is drug A, what you say is drug A is not more successful than the generic. Now, successful than the generic. Okay. No, is not more successful. Nothing has changed. Null hypothesis, nothing has changed. Alternative hypothesis, something has changed.
The drug company claims.
Yeah, but they claim that it was successful in the case of 296.
Yeah, so drug A is not more successful than the generic drug. Would you like me to
explain that, please?
Just to be sure about this, guys, whatever statistic they give you in any question, such as this 51% here, okay, that is always going to be your null hypothesis, right? It's consistent with any question we've seen so far. So what you say is drug A is not more successful than generic drug. Hence, it's still 51%. Now, there's two ways to go at this, okay? We'll do both ways and we'll explain why we're going to use one over the other. Your two choices are 1 over root n or 1.96 times the square root of p 1 minus p all over n. They are your two choices in this question. Because you're given a statistic of 296 over 500, the p option is available to you. So it's going to be 196 multiplied by, what is it, p is, what's,
0.5.
so p is, yeah, you're right, 296 over, which is 0.592, 1 minus 0.592, all over the square root of 500, okay? Now that answer should give you, I have it here somewhere, 0.043, just check it out for me. 0.043. Now, will somebody else try 1 over the square root of 500? Okay, and what do we get for both of them?
Did you multiply 1.96?
I did indeed, yeah.
0.044.
Okay, 0.044, and the other one? 0.043, I'm hoping. 43? Yeah. Now guys, what is the difference between the two of them? Absolutely nothing. Okay. Now what we're going to say is that this here is an approximation of the 95% confidence interval. It is not the 95% confidence interval. So regards to the language of the question, if you can find a p-value, this one is always your option. If you can't find a p-value, well, there's no confidence interval to be made. Okay, so bottom line is you're always going to go with this one. I'm going to show you the one exception later on where you're going to use the 1 over root n. Is that right? Now, what happens next is this 0.043, okay? You're going to, your statistic is what was this again? 0.592. Remember, your range is 0.043 below this and 0.043 above it. So 0.043 below is 0.459, I think. And then 0.043 above it is 0.635. Now, what happens here, guys, is that you notice that you're 51%. It's not even within the margin of error. So an example would be, what this margin of error means is that if I was to test this drug again, now we know this drug is successful 59.2% of the time, correct?
Yeah.
If I did this test again and I got 63.4, 63.4 is still within the 95% tolerance, therefore you'll claim nothing has changed with our drug. However, if I get a result for a similar test that is above or below this range, then there is cause for concern that the drug is not as effective as previously thought. Now, are we going to accept the null hypothesis or reject it? Reject, because we're claiming that this is more effective. Do you understand? It's more effective. It's more successful.
Not more successful.
But that's what it says, right? Drug A is not more successful. So that's claiming that nothing has changed. It's still working off 51%, 0.51, according to the original statistic. It's not working at 51% anymore, because 51% isn't in this confidence interval. It's clearly a superior drug. Drug A is superior than the last one, so we're going to reject the null hypothesis. Okay? Now that we've done that, because 0.51 is not in this interval. Okay? Now, brings me on to the second question, okay? What the next question says is, the null hypothesis was accepted for drug B. Estimate the greatest number of patients in the trial that could have been successful with drug B. So, once again, if we can... so I'm just going to bring this all down here, right? Drug B, I'll call it drug B in a second. I'll just write that down now. Drug B is not more successful than the generic drug. Now, what we're saying is, if it's still accepted, it's at the 95% margin of interest, right? So it's your 1.96 square root of p, 1 minus p, all over n. Okay? Now 0.51 is 51%. And we already know that 0.043 is our margin at the 95% confidence interval, right? Now, because we would use this, and we used this in part 1, that is because we were given a statistic, a proportion for drug A. The proportion for drug A was our 296 out of 500 patients, hence why we could use this equation. There is no proportion for drug B, so to find an interval for drug B is using a proportion can't happen, okay? So what we're going to say next is we can't use this 1.96 root p 1 plus p over n. So therefore we're going to have to use 1 over the square root of n. We already determined that 1 over root 500 is 0.044, right? Now this 0.044, we're going to add it on to this one here, okay? And what do we get then? 0.554. Everybody happy with that? And then the lower value would be 0.51, take it away. Anybody? 0.51 take away 0.044. Sorry? 0.466, okay? Now, let me explain what this means. It means at the 95% interval, using this approximation of the 95% interval, my drug will remain the same if my test scores anywhere between 0.466 and 0.554. It's considered to be within the margin of error. The drug is still considered to be 51% effective. If I got a score of 43%, it's clearly outside this interval. Therefore, we consider whatever drug we tested to be less effective than the drug, our original 51% drug. However, if we score a result of, let's say, 0.58%, that's clearly outside this region here. So our drug B would be considered to be more successful. However, in this question, it states that we accept the null hypothesis. Does everybody get that? We accept the null hypothesis. If we accept the null hypothesis, this means that the drug B is still 51% effective. It is not any more effective than the generic drug that came before it. 1 second. Therefore, the maximum allowance we're allowed to have is we're allowed to have 0.554 at best. Then this 0.554 multiplies by 500, and how many people did we test against? 100, was it? 500 multiply 0.554 by 500, and what you get?
277.
277. Okay, that's the answer. Whelan.